Student, today we will learn the chapter differentiation, next part. In this chapter we will discuss using the first principle of product function. Let here are we have to going to take the differentiation with respect to x of two functions fx and gx by using first principle. Okay, how we will get it? So using the first principle we can write here fx plus h gx plus h minus fx into gx upon h. H tends towards 0. Now you have to write here fx plus h gx and subtracting fx plus h gx. Okay, and adding also, this you have to learn it, fx plus h gx and write this step again plus fx gx upon h. H tends towards 0. This 2 point you have to learn it. You have to subtract this and add this. Okay, fx plus h gx. Now taking the common fx plus h here and taking the common gx here. Okay, what we get here? Fx plus h in bracket, here is gx plus h. Gx plus h. Okay, and here is also minus fx plus h gx plus h, this one, fx gx this one, minus we have subtracted and add it. Now taking this common fx plus h, what we get it? gx plus h minus gx, and taking common here gx, what we get in bracket? Fx plus h minus fx. Okay, this you should be understand. Now dividing by h, here also and here also, taking the limit. Now what we get here? Fx plus h, h tends towards 0, and differential of gx plus gx and differential of, you can check here, this one is the differential by first principle of gx and this one is the differential of fx. Limit here we can putting fx. So student, we can find out the basic formula, that is fx into gx. We can write here fx, limit of this, and differential of gx plus gx into differential of fx. Okay, this way you can use the product formula. Okay, now if we want to be using the formula for three functions, let a, b and c, so using this 2 times, a into bc and bc again you will use. So what you get the formula? Differential of a into b into c plus a into differential of b into c plus a into b differential of c. This way you can use the formula for 4 functions also, a, b, c, d. First cut differential into second and third plus first into differential of second and third plus first into second differential of third, and so on. You can use this formula for a, b, c, d more function also. Now for quotient formula, differential of numerator and denominator if there are two functions. Okay, now how we will use this formula? Using the first principle. So we can write n plus x upon d plus x minus n upon x n upon d upon h tends towards 0. This is the first function, the second function numerator and denominator. So this way you can use this fx of this and this formula. After taking the differential limit, you can find the product formula for numerator and denominators. Okay, for convenience we are writing here fx upon gx, right here fx plus h gx plus h minus fx upon gx. Okay, it is numerator, it is denominator. So taking the LCM here, gx plus h gx, we are writing here fx plus h gx minus LCM here. Okay, gx plus h into fx. Now you have to learn what we have subtract here and add here. So we can writing here x plus h gx minus fx and gx. This point you have to learn, minus fx gx. Okay, and minus gx plus h fx so you write here again adding here plus fx gx. Okay, upon gx plus h into gx. So this is very important to add or subtract. Okay, now taking the common here, but we take the common gx, and now we can write fx plus h minus fx minus, taking common here, we can common here fx, we can write gx plus h minus gx. Okay, upon gx plus h into gx. Now if we divide h here and h here, what we can here, gx and fx plus h minus fx upon h tends towards 0 minus fx and gx plus h minus gx upon h tends towards 0 and divided by gx plus h gx. Divided by gx plus h gx. So we can write here equal to gx into f dash x minus fx into g dash x upon gx into gx. So differential of fx upon gx is gx into f dash x minus fx into g dash x upon gx whole square. So we can say formula of numerator upon denominator equal to denominator into differential of numerator minus numerator into differential of denominator upon square of denominator. This way you can use this formula. Okay student, so we have learned in this video the formula for multiplication and division. Now we will solve some questions on this topic. After that, in the next video we will learn the differentiation for composite functions and other types of the functions. So now we will going to be solve some questions on this topic using the first principles. If it is said in the questions, then you will use the first principles, otherwise you can directly find the questions. Okay, so now for revising this topic we will do some questions here. Let y equal to x to the power 3 plus 3x square plus 2. So we are getting the differentiation of this x cube plus 3x square plus 2. Okay, now these are in the term plus minus, so we are taking the differential separately. Okay, in starting you should be use each and every formula. After that you can use directly. Okay, taking the constant here outside. Okay, now x to the power n x to the power n minus 1, x to the power n x to the power n minus 1, constant 0. So this way, if you learn the basic formula, okay, then you can solve the answers. Now if the questions is this way, next question, x to square plus sin x, we can write separately x square plus differential of sin x. Okay, now it is the x to the power n, sin x differential is cos x. If you know the formula, then you can write easily. Now let another question by product formula, let x square sin x. Now we know the formula, differential of x square into sin x plus x square into now differential of sin x. This way you can use the formula. Now x to the power n and x to the power n minus 1, and sin x is cos x. So you are getting formula separately. So you know the formula if multiplication, division and exponent, so you can solve easily. That is, the question is x square upon sin x. So using division formula, we know the formula, denominator into differential of numerator minus numerator into differential of denominator upon square of denominator. Now again, okay, so go through regularly exercise, then you can find the answer very easily. Okay, so in the next video we will do some more questions by first principle also, and question on this direct formula. Okay, thank you for watching.